Good day, ladies and gentlemen, once again. We are now in the fourth chapter, as highlighted in the theory and the previous examples. And this recording is on example 4.19. And we are still in chapter 4, which is the chapter on probabilities, the chances of something happening or an event occurring. And we are presented with the information. Before I read the heading, the information in a table format, kind of looking like a contingency table that we dealt with in the beginning. And we mentioned in the contingency table that information can be presented in tables. And probability, this information is also presented in a different format, similar to that of contingency table. And it says the personnel department of a company analyzed the qualification profile of their 129 managers. So 129 is the population, meaning it is the total number of people in this department. And we can see it also there under the total in our table that these are the 129 managers that this company is having. So definitely this must be a big company or a large company. The qualification level is the highest qualification achieved by a manager. And we can see on the table that we have the qualification level where the manager can have metric. Very surprisingly, we can have managers who only have metric. And either the manager has a diploma or either a manager has a degree. Then we have the departments where these managers are heading or are leading, which is being a section head and or being in a departmental head, and another one is a division head. There is not much difference between section head, departmental head, and division head, but I'm not going to be going in details on that, but it's more of a department, heading a department. Then we are provided with this table of the managers and their qualifications and the departments, divisions, or sections that they are heading. We have 28 those that have metric and 14, but we are not given the number for the division head. A division head that is having metric is not provided. So first of all, when it comes to probabilities, is to complete the missing figures. And we know that this total is the total of 28, and 28 minus 14 minus 6 will give us the missing number for the metric manager, that is a division head. So we can say if 28 is the total, we minus the available one, 14, and minus 6, this will give us 8. That means there are 8 managers who only have metric and they are the division head. Then when we are looking for the total, very easy, it will be 14 plus 28 plus 8. Then we'll say 8 plus 14 plus 28. Then this gives us a total number of 50. That means there are 50 managers in this company who only have metric, of which out of this 58 are division heads, and 14 are departmental heads, and 28 are section head. With only metric qualification, you can manage. Then with those who have diploma, there is no missing information regarding managers who have a diploma, but we have missing information with the manager that has a degree and is a section head or is the head of the section. Then again, total is 53 minus 28 minus 20. It will give us the missing number, which is the section head that has a degree. In terms of the total, how many of them? 53 minus 20 minus 28, it gives us 5. So we have 5 section heads who only have a degree. Then another missing one, it is the total of the managers of this company who only have a degree in total. So that will be 5 plus 10 and plus 14. Then if we add those three, we get to 29. So there are in total 29 managers in this company who only have a degree, no honors, no masters, and no PhD. Then we are now going to be responding to the questions regarding the information that is provided to us. Please, at the back of your mind, have the knowledge that we have 129 managers in this company that we are analyzing. First requirement says complete the table. We have already completed the table, meaning we got our mark for the completion of the table. Requirement number B says, what is the probability of a person selected at random having only metric? What are the chances that the person that we select at random will only be having only a metric qualification as a manager? Now, in other words, we need to look at metric, meaning only metric. We look at the total of those that only have metric, and if we look at metric, there is the total 50. Remember, they did not say metric and a section head, or metric and departmental head, metric and or being a divisional head or division head. No, they did not say that. They said, what is the probability of the person being selected at random having only metric? So our focus is only in the total of those that have metric, which is 50. Then we divide by the number of managers that this company is having. So now that will be 5 divided by a total of 129 managers this company is having. So that will be 5 divided by 29. It is 5 divided by 129. So that is the probability that they are looking for. And we can leave it there. We don't have to take it into decimal places. Please leave it as a fraction unless stated otherwise. Then now we are still continuing. Remember, this is number B. Number B is Roman figure 1, Roman figure 2, Roman figure 3, and it continue. So the question says, what is the probability of a person selected at random being a section head and having a degree? Now there are two things. This person or manager must be a section head and must have a degree. What are the probability of us at random selecting a person of that qualification and that position? Now what are we doing now? We look back in our table. It says being a section head and having a degree. Now we go to section head. Remember, on the left we have qualification level. So now we scroll down up until we get to a degree. This person is a section head and having a degree. When we arrive at the degree, then that is the number we are looking for. We say it will be 5 divided by 129. 5 divided by 129. So that will be 5 divided by 129. We always divide by 129 unless there is a word given. If there is a word that says given, then we divide by what is given or what is after the word given. So that is why we still take the total of all the managers in this company. So the chances of us being a section head and having a degree, of a manager being a section head and having a degree, is 5 out of the total of 129 managers in this company. Roman figure 3 says, what is the probability of a person? Remember, this is the main question. What is the probability of a person selected at random? What is the probability of a person selected at random being a departmental head given? Whenever there's a word given, and I put this word bold, whenever there's a word given, you always divide by what is given. So now, meaning we don't divide by 129 anymore, but we divide by what they say it is given to us. So they say, what is the probability of the person being selected at random being a departmental head, given the fact that they have a diploma. So when they say given they have a diploma, that means we divide by the total number of those who have a diploma. As I said to you, immediately when they say given, you take the total of what is given, and the total of those that have diploma is 50. So we already know that we divide by 50, meaning dividing by whatever is given. Sometimes the question can say, given they have a diploma, what is the probability of the person selected at random being a departmental head? So they can start with the word given. It's not always at the end of the sentence. So the question said being a departmental head. Now we need to go to our departmental head and look at the number of the department head. Department head, how much do we have? Oh, there's a number that we still that is missing there, the total. Let me just do the total. I just by mistake forgot it. 14 plus 24 plus 10, that gives us 48. Now we say, what is the probability of this person being a departmental head given that they have a diploma? Now we go to departmental head. When we get to the given, remember, which is the diploma, then we take that number that is aligned with what is given, which is 24, total of 24. Then we divide by 50 whenever it says given. In this case, the probability of selecting the person at random being a section head given that they have a diploma will be 24 divided by what is given. So now we don't take the total, no, we stop where it says given. So it's a section head given that they have a diploma, so that will be 24 divided by 50. So now this will be our probability. We say 24 divided by 50. Whenever there is a word given, you divide by what is given, then you take that middle number that crosses the section head when you reach to those that have a diploma. So whenever again we have given, we divide by what is the number, the total number of what is given. So this will be by 50. Just trying to delete there. Remember again, we are under Roman figure 5. What is the probability of a person selected at random? What is the probability of a person selected at random being a division head or a section head? Take note, now it's or. Being a division head or a section head. Being a division head or a section head. Now it's a division head or a section head. The word very important, because at this point there will be a point of intersection. There will be a point of intersection at this point whenever there's a word or, most of the time. Now we look at the total division head and total section head. The probability of being a section head is 53. The probability of being a division head, it is 28. So we have 53 plus 28. Fortunately, in this case, there is no point of intersection, but I will tell you when there's a point of intersection where you need to deduct some numbers. Now it will be 53 plus 28 divided by the total number of 129. In this case, it's only the word or is not given, so we take the total of 129. Probability of being a section head is 53 plus probability of being a division head is 28, all divided by 29. Now that will be how we respond to this question. 53 plus 28, then that will be the response to this part of the question. It will be 53 plus 28 all over 129. Remember, this is 53 over 129 plus this is 53, just to explain it further, 53 divided by 129 plus 28 divided by 129. So what do? We take the base and we keep the indices. It's 129 or to the power 81. So this is where everything is coming from. just to say it further. So it's a probability plus another probability. Then this will be equal to 81 over 129. The probability of being a section, a division head, being a division head or a section head, a division head or a section head. There we have a division head and we have a section head. So that is very simple. Again, dividing by the total, dividing by the total. And I want to bring you to number Roman figure 2. Roman figure 2 said and having. Take note, under or we just took the total, but here it says being a section head and having a degree. That is why now we scroll down. They said being a section head and having a degree. So we said section head, scroll down. When we get to a degree, we need to stop. So that is why we stop there, because there's a word and, meaning being a section head is not a total. Probability of being a section head or no is and. So when there's an and, you look for the point of intersection. This person must be a section head and must have a degree. Then you take that number 5. But when it says probability of being a section head or a division head, you just say, oh, section head total. We don't have classification in terms of the qualification. Take note, the qualifications are not in place. But in the case where there was and, we had to say, oh, you must be a section head. Not only a section head, but there must be a qualification that is aligned to your position. So that is why now we had to take that number 5, not 53. Now we continue on that same note. Now it says under Roman figure 5 that what is the probability of the person being selected at random having metric given, take note, having metric given the person is a departmental head, that the person is a departmental head, given the person is a departmental head, meaning we divide by the total of what is given. Remember, the total of what is given, meaning we take the total of the departmental head. We look for the total of the departmental head, which is department head. Department head is 48. So we take the 48 of the department head, we divide by it, because we always divide by what is given. Then it said having metric. So now we say we have to look for those who are having metric given they are departmental heads. That means we look for the metric, but we don't take the total of those who are having metric. We look for the metric who are the departmental head. So now let us go there to our table, and I hope it will be easy also for you to grasp this. Having metric, is it 28? No, because this is the section head. Having metric, do we take the 14? This is for the department head, and they said department head. So that's what we're looking for. Having metric given you are a department head. So we take the number 14 in this case. 14, those who are having metric, and they are the department head. So we say 14 over 48. So that is why the correct number here will be 14. Then we go to Roman figure 6. What is the probability of the person being selected at random, being a division head or having a diploma? Being a division head, then we go to the division head, being a division head. Then we go to our division head, and I think there will be the point of intersection here. Being a division head, being a division head. Being a division head, it is 28. We can see that. Let us look for the second one. Being a division head or having a diploma. Do you see the word or? Being a division head or having a diploma. And I said to you that whenever there is this connector, forgot the English name for it now, if it's called the connector. But when we have the word or, we take the total, always. The total and the total and the total. And we take all 129 or the population. So now we took the total of the division head. and we took the total. We must take now the total of those who are having a diploma, and we need to look for that point of intersection that needs to be deducted. There is sometimes the number that will be duplicated. Now let us look for that. We need to take the total of those who are having a diploma. Let us go to our table. We have taken the number 28. Then now those who are having diploma, what is their total? Their total is 50. Those who are having diploma. So we say plus 50. Look, remember, we said we are looking for those who are division head, which is 28, and those who are having a diploma. That remember the word that combined that sentence is or. Now, if you can see, when we went down here calculating this 28, we used the number 6. It was 8 plus 6 plus 14. When we crossed here, we said 20 plus 28 plus 6 plus 50, meaning the number 6 is duplicated. So now we need to say minus 6 in this case. All divide by 129, the total population. I said again, when there is or and you are taking numbers that are intersecting, this number at the point of intersection will be duplicated. Therefore, now you need to deduct it immediately in your answer. So it will be 28 plus 50 minus 6, because the number 6 appears when you go down and the number 6 appears when we go horizontal. So it will be 28 plus 50 minus 6. But remember, again, I want to highlight it to you that in this one we did not do it, yet there was the word or. Why? Because we were dealing with the division head and the section head. So it was division head going down and section head. So there was no point of intersection, although the word or was there. So please take note of this. So now in this last one, we have 28 plus 50 minus 6, all divide by 129. Then let us take our total and we close our probability question example 4.19. Then it will be 28 plus 50 minus 6, we get 72. So this will be 72 over 129. And this will be our answer to the question. Last question is, other events in number 4, just verify if that is a real number 4. Under number 4, mutual exclusive. Now remember, being mutual exclusive meaning is the events that cannot occur simultaneously. Now we go and look at number 4. Number 4 being a division head or a section head. Yes, you can be a division head and a section head. So at the events, you cannot be a division head, and being a section head. So these events are mutually exclusive, meaning they cannot happen simultaneously. So now, are the events in number 4 mutually exclusive? The answer is yes, because they cannot be done parallel, or they cannot happen simultaneously. So these events are mutually exclusive. You cannot be a section head and a division head at the same time. With that, guys, thank you very much. Now the next one will be example 4.20.